Every single time you check your bank balance, order food online, or scroll through your social media feed, a massive invisible engine is working behind the scenes to find exactly the right data for you in milliseconds. That engine has a name, and today you're going to understand exactly how it works. Welcome. In this video, we're breaking down database management systems, what they are, how they work, and why they matter to literally every digital experience you have. By the end of this video, you'll understand the core concepts of DBMS, how data is organized and retrieved, and why this technology is the backbone of the modern information world. Let's get into it. Section 1. What is a database management system? Let's start with the basics. A database is simply a collection of organized data. Think of it like a massive, incredibly well-organized filing cabinet. But here's the thing. A filing cabinet on its own isn't very useful if you can't quickly find what you're looking for. That's where a database management system, or DBMS, comes in. A DBMS is software that acts as the middleman between you and the raw data. It lets users create, read, update, and delete data without ever needing to know exactly where or how that data is physically stored. So when you type your name and password into a login screen, you're not directly touching the database. The DBMS is handling that request for you. It checks your credentials, finds your account, and either lets you in or blocks you, all in a fraction of a second. Some of the most well-known examples include MySQL, Oracle, Microsoft SQL Server, and PostgreSQL. These systems power everything from small websites to global banking networks. Now here's a question worth sitting with. If the DBMS is the middleman, what rules does it follow to make sure data stays accurate and safe? That brings us to something really important, coming up next. Section 2. Data models and structure. Every DBMS needs a way to organize data logically, and that's where data models come in. The most widely used model today is called the relational data model, developed back in the 1970s by a researcher named Edgar Codd, and it fundamentally changed how we store and access information. In a relational model, data is stored in tables, kind of like spreadsheets. Each table has rows and columns. Each row represents a single record, like one customer. Each column represents an attribute, like that customer's name, email, or phone number. What makes this powerful is the idea of relationships between tables. Say you have a table for customers and a separate table for orders. Instead of copying all the customer information into every order record, you simply link the two tables together using a shared piece of data called a key. This keeps things clean, efficient, and consistent. You update a customer's address once, and every order linked to that customer instantly reflects the change. There are other data models too. Hierarchical models organize data in a tree-like structure, and network models allow more complex connections. More recently, NoSQL databases have become popular for handling unstructured data, like social media posts or streaming video. But the relational model remains the gold standard for most business applications. So we know data is stored in organized tables with relationships between them. But how do you actually pull the exact data you need from a system that might contain millions of records? The answer is surprisingly elegant, and we're covering it right now. Section 3. Querying data with SQL. To talk to a relational database, you use a special language called SQL, Structured Query Language. Don't let the word language intimidate you. SQL is actually one of the most readable programming languages that exists. A basic SQL command looks something like this. Select name, email from customers where city equals Chicago. In plain English, that's just saying, give me the name and email of every customer who lives in Chicago. Simple, right? SQL has 4 core operations that are often called CRUD: create, read, update, and delete. Every interaction with a database can be reduced to one of these 4 things. You're either adding new data, retrieving existing data, changing data, or removing it. What makes SQL so powerful is that it's declarative. You describe what you want, not how to get it. The DBMS figures out the most efficient way to retrieve the results. That's like ordering food at a restaurant. You tell the server what you want, and the kitchen figures out how to make it. SQL is used by developers, data analysts, business intelligence teams, and even everyday users who don't realize the forms they're filling out are building SQL queries behind the scenes. But pulling the right data quickly is only part of the story. What happens when multiple users are trying to access or change the same data at the same time? That's where things get really interesting. Section 4. Transactions and Data Integrity. Imagine two people trying to buy the last concert ticket at the exact same moment. Without proper controls, both purchases might go through, and the venue would oversell the event. This is a real problem, and DBMS systems solve it through something called transaction management. A transaction is a sequence of operations treated as a single unit. It either completes fully or not at all. This is governed by 4 properties known as ACID, atomicity, consistency, isolation, and durability. Atomicity means all steps in a transaction succeed together, or none of them do. If your bank transfer fails halfway through, you don't lose money. The system rolls back to where it started. Consistency means the database always moves from one valid state to another, no half-finished records or broken links. Isolation means transactions happening at the same time don't interfere with each other. Your ticket purchase and someone else's happen as if they're the only ones in the system. Durability means once a transaction is confirmed, it stays confirmed, even if the power goes out a second later. These 4 properties are what allow millions of people to use the same system simultaneously without chaos breaking out. And speaking of keeping things in order, our final section covers how DBMS systems protect and organize data at an even deeper level. Section 5. Database Administration and Security. Running a database isn't a set-it-and-forget-it situation. Behind every major database system, there's usually a dedicated database administrator, or DBA, whose job is to keep everything running smoothly, securely, and efficiently. Database administrators handle things like user access control, deciding who gets to see what data and who can change it. They manage backups so that if something goes wrong, data can be restored. They also monitor performance, making sure queries run fast even as the database grows. Security is a major concern. Sensitive data, think medical records, financial information, personal details, must be protected from unauthorized access. DBMS systems use encryption, authentication protocols, and detailed activity logs to keep data safe. There's also the concept of normalization, the process of organizing tables and relationships to reduce redundancy and improve data integrity. A well-normalized database is lean, efficient, and much easier to maintain. As organizations collect more data than ever before, the role of database management has only grown in importance. From healthcare to e-commerce to government services, a well-managed database is the difference between an organization that runs smoothly and one that collapses under the weight of its own information. So let's bring it all together. DBMS is the software that manages organized collections of data. Relational models structure that data in connected tables. SQL lets us communicate with those tables clearly and efficiently. ACID transactions ensure data stays accurate and reliable under pressure. And database administrators keep the whole system secure and optimized. This is the invisible infrastructure that makes the digital world possible. If you found this video helpful, please hit the like button. It genuinely helps this channel reach more students just like you. Subscribe so you don't miss the next video in this series. And drop a comment below with one question you still have about database management systems. I read every single one, and your question might become the next video topic. See you in the next one.